We will continue our review of solving systems of equations by looking at a system with three variables, and we'll do it by elimination. Let's take a look at this system. 3x plus 2y minus 2z equals negative 13. X plus 2y plus 3z equals 5, and 5x plus 3y minus z equals negative 11. Let me be sure I copy that down. 3x plus 2y minus 2z equals negative 13. X plus 2y plus 3y equals 5. 5x plus 3y minus z equals 11. It's always good to double check to make sure that you copied a problem done correctly. Now we're going to use the system that we used with two variables to cancel variables in order. I will cancel the x variable first, then the y variable, and then we will have z left. I'm doing this because when we go into the study of matrices, that's the order that we will be doing the eliminations. So let's take these first two. We'll multiply by 1 and negative 3. And we'll take the second two and we'll multiply by 5 and negative 1. So taking the first two, I have 3x plus 2y minus 2z equals negative 13, multiplying by 1. Then multiplying by negative 3 in the middle. Negative 3x minus 6y minus 9z equals negative 15. Now we add these together, and I get negative 4y minus 11z equals negative 28. Negative 4, negative 11, so negative 4y minus 11z equals negative 28. And that's the first one we get. Now we'll take and multiply 5 and negative 1 times the bottom two equations. 5x plus 10y plus 15z equals 25. And negative 5x minus 3y plus z equals 11. Add these together, we get 7y plus 16z equals 36. 7y plus 16z equals 36. Now we have a system of two equations with two variables. So now we will apply our method to this one, multiplying by 7 and 4. And that will give us negative 28y minus 77z equals negative 7 times 8 is 56. 14 and 5 is 19. 196. And multiplying the second one by 4, we'll get 28y plus 64z equals 4 times 6 is 24, 12, 13, 14. Adding these together, we get 2, negative 52, and here we have negative 13z. And 52 divided by 13 is 4, so z equals 4. So that ends up with z equals 4. if we were to write this in this order, one equation from this first iteration of the system, 3x plus 2y minus 2z equals negative 13, then you have, from that, I erased it. Well, no, negative 4y minus 11z equals negative 28. We'll use that equation. And then you have z equals 4. All right. I erased the work, but not the equations. Very good. Notice that now we have the equations written in descending numbers of variables, killing the first one and killing the second one and ending up with the last one. Now we can go back and find each of the other variables by substitution. So putting 4 into the equation above gives me negative 16. Oh, sorry. 4 goes for z. Negative 4y minus 44 equals negative 28. So negative 4y equals negative 28 plus 44, which is 16. And that gives me y equals negative 4. And now I take that and plug it into the top equation. 3x plus 2 times negative 4 minus 2 times positive 4 equals negative 13. So 3x minus 8 equals negative 13, which gives me 3x equals negative 13 plus 16. 3x equals 3. X equals 1. And there we have our solution. It's 1, negative 4, 4. Listing them in alphabetical order. Let me do another example, just again so you can see the steps that we're using. Using the elimination method to eliminate x from the first two equations and from the second two equations, and that gives me two equations where x is eliminated. Now I have a system of two equations and two variables. I use elimination again to eliminate y, and I have the value of z. Once I have z, then I have a descending order of the system written in an order of descending number of variables. I can use each one, z equals 4, plug it into the one above, use y and z to plug it into the top one, and then you find x. That's the method that we use with three variables. Notice it's simply the application of the elimination method in two variables multiple times. Let's take a look at this one. 7x plus 5y plus z equals 0. Negative x plus 3y plus 2z equals 16. X minus 6y minus z equals negative 18. So there's our system of equations. Press pause, work this out for yourself, and then you can come back and follow my work and your work and see if you get the correct answer. The first time I tried this, I got it wrong, so don't feel bad if you make a mistake. It's easy to make simple mistakes in some of these problems. All right, let's take the first two equations. I'm going to use 7 and 1. 7 and 1. That gives me 7x plus 5y plus z equals 0. That one did not change. And the other one becomes negative 7x plus 21y plus 14z equals 112. Adding these together, we have 26y plus 15z equals 112. So I'll write that up here. 26y plus 15z equals 112. Now we'll do the same thing with the bottom two equations. Well, that's just 1 and 1. That doesn't change the equations at all. So I could just add them up without having to rewrite them. X and this is 0. This is negative 3y plus z equals negative 2. So negative 3y plus z equals negative 2. Now I have a system that's two equations with two variables. So now we will use these numbers, reverse them, 3 and 26. And I get 78y plus 45z equals 336. And the bottom one, negative 78y plus 26z equals negative 52. When I add these together, I get 71z equals 284, and from that we get equals positive, 284. Dividing by 71, we get z equals 4. So now we have z equals 4. I have now basically solved the system. It's just a matter of substituting. Again, just for future reference, we can now rewrite the system this way. 7x plus 5y plus z equals 0. The next equation would be this one, 26y plus 15z equals 112. And the last equation would be z equals 4. Notice descending number of variables, and now we can substitute back. To find y, 26y plus 15 times 4 is 60 equals 112. So 26y equals 52, and y then equals 2. And now substituting it all back in to the first equation, 7x plus 5 times 2 plus z, which is 4, equals 0. So 7x plus 10 plus 4 equals 0. 7x equals negative 14, so x equals negative 2. And there's our solution, x equals negative 2. Well, we'll write it as a ordered triple. Negative 2 for x, 2 for y, and 4 for z. If you got that on the first try, great job. This method can be extended, of course, to 4 equations and 4 variables, and 5 equations and 5 variables. It just becomes a longer and longer chain of eliminations every time you add another set of equations. Fortunately, as we learn matrices, there are faster ways of doing systems that have more than just 4 variables and 4 equations in them.